All right. Hello again. Let us do the last part of the lesson on solids. And something very important that we need to look at is the idea of net shapes. All right. So let's begin. I'll start off by saying to you that net shape is the shape that results when a solid is pulled apart and flattened. All right. So if you have, let's say, a hollow solid. For example, like a tin can, I mean, that's a solid shape and it's hollow. Um, the shape that results when this shape is what? Pulled apart and flattened out is called the net shape. Remember, we're looking at solid shapes with a uniform cross section. All right, here's the next point. All solid shapes with a uniform cross section opens out into a rectangle. So once you have a solid shape with a uniform cross section and you open it out and flatten it out, that shape is going to open out into a rectangle. Now, since it is the solid that became the rectangle, there has to be connections between the solid and the rectangle. These are the connections. Now, the perimeter of the cross section of the solid, the perimeter, the perimeter of the cross section of the solid becomes one length of the length of one side of the rectangle, and the height of the solid becomes the length of the other side of the rectangle. All right. So this is it would be really cool to actually show this to you, but I really can't do it now. But it's something that if you think about it a little, you can imagine it. All right. When you open out this solid shape, it becomes a rectangle. All right. So let's take a look at some net shapes. This is the net shape of the cuboid. This is a net shape of a cuboid. And this would be a closed cuboid. Closed meaning that it has a top. Is that a top? Maybe you could consider this to be the top. And it has a bottom. All right, so it's a closed shape. But notice that the middle section of the what? The middle section of the solid opens out into a rectangle. The middle section of the solid opens out into a rectangle. So which brings me back to the first point that I made. All solids with a uniform cross section opens out into a rectangle. And as I said before, since it is the solid that becomes the rectangle, there has to be connections between the solid and the rectangle. All right. So this is the connection. Notice here you have what? Length, width, length, width. So that is the cross section. The cross section of the cuboid is a rectangle. This is the uniform cross section. Now, when you open this out, so length plus width becomes the perimeter of the cross section. The perimeter of the cross section, when you open out the shape, becomes the length of one side of the rectangle. So this is length, width, length, width. So that is the what? The perimeter of the rectangle. Now the height of the solid becomes, this is the height of the solid, becomes the length of the other side of the rectangle. So we're looking at net shape and we're learning that the middle part of a solid shape with a uniform cross section opens out into a rectangle, and then the shaded portions at the top and the bottom is the what? The top and the bottom of the closed cuboid. But the middle section opens out into a rectangle. This is true of all solids with a uniform cross section. Let's have a look at the cylinder. Here's another example of a solid shape with a uniform cross section. And here's what would happen. Let us say we take a scissors. Let's say that this is paper, or it's paper tin. It's paper, and I use a a scissors and cut along this line here. Cut along this line and then open the shape out. Pull in that direction, pull in that direction. If I open this shape out, the shape is going to open out into a rectangle. Down here, is the perimeter or the distance around the rectangle, sorry, the cylinder, and the perimeter, the cross section of a cylinder is a circle, so the distance around is called the circumference. When you open this the cylinder out, this length here from here to here is the circumference. So the circumference becomes the length of one side of the rectangle, and the height of the solid becomes the length of the other side. All right, and the shape at the top and at the bottom are the two ends, the top and the bottom of the cylinder. So this is what you get when you open out the solid, and when you open the solid and flatten it out, the shape that results is called the net shape. All right, let's look at a related question. This is a question from your workbook. It's question number 15 on page 168. All right, so here it goes. Pi in the question, you must take pi to be 22/7. So it says the rectangle TUVW represents a sheet of metal whose length UV is 100 centimeters. So UV is 100 centimeters. All right, let's change the color here. UV is 100 centimeters. All right, let's write that back again. So UV is 100 centimeters, and its breadth WV is 88 centimeters. So this is 88 centimeters. All right. It says the sheet of metal is formed into an open cylinder. Open cylinder means that it has neither top nor bottom, or one side could be. So if it's open, it has neither top nor bottom. If it's a container, it would have what? Bottom, maybe bottom, but not necessarily top. All right. So it's formed into an open cylinder by bringing T onto U and V onto W. So somebody takes this end at T and brings it around to join what? For the two ends to connect, T and W, T and what? U to connect, and for what? W and what? V to connect. This is something that you could try for yourself. You should get any sheet of rectangular paper and bring and fold it to bring opposite ends together, and you'll see that the rectangle folds into a cylinder. It says the first thing says sketch a diagram of the cylinder and clearly mark in 100 centimeter as a dimension of the cylinder. All right, so we could do it in this empty space here. So let's do A in this empty space here. So let's do a sketch. All right. All right. All right. So I'm sure that let's try and make this look pretty. One more time. All right, good. So we just made our sketch. And so this is an open cylinder. So open cylinder means that it has no what? Open cylinder means that it has no top and it has no bottom. All right. And how did we form this? They formed this by bringing these two ends together. So you brought the ends T and U together, and at the other end, it is what W and what V. So you brought these two ends together to form this cylinder. All right, and obviously, the length VU did not change, or TW, that length didn't change. This length from here to here, this length, the height of the cylinder, is 100 centimeters. All right, so this would be the answer to A, minus these arrows. You don't need them. All right. All right, so this would be the answer to A. B, calculate the radius in centimeter of the base of the cylinder. All right, remember, if you guys visualizing this, if you're interpreting it properly, you should interpret that it is that WV becomes the base of the cylinder, and the length of WV is what is 88 centimeters. Bear in mind they didn't cut the sheet, so WV remains 88 centimeter. But the WV which over here, WV is the length of one side of a rectangle. Over here, WV is what is the circumference. So let's go on to B. So B, to calculate the radius of the cylinder, we're going to calculate it using this knowledge that the circumference, which is 2 pi r, is equal to WV, which is 88 centimeters. So let's put in what we know. This is 2 times pi, which is what? 22 over 7, times what we don't know, the radius, will give you what? 88 centimeters. Again, the length WV became the what? The circumference of the base of the cylinder. So if I put this over 1, put this over 1, multiply the numerator. 2 times 22 is 44. 44 times r is 44r. At the bottom, 1 times 7 is 7. 7 times 1 is 7. Your 44r over 7 is equal to, let us say, 88 over 1. Okay, do the same thing up here. Now, if I have one fraction is equal to one fraction, what I would do is I would cross multiply. So 1 times 44r is 44r is equal to 7 times 88. I would divide both sides by 44. So over here 44 goes and leave only r, is equal to 44 into 88 goes 2 times. 2 times 7 is 14 centimeters. The radius of the base of the cylinder is 14 centimeters. All right, let's see what else they want for us to find out. We're asked to calculate the area of the base of the cylinder. That's not difficult. All right, so now we just calculated the radius, and for the radius we got 14 centimeters. All right, so let's calculate the area here, the shaded area there. So it's a circle, so C area is equal to pi r squared, which is equal to 22 over 7 times 14 over 1 times 14 over 1. 7 into 7, 1, 7 into 14, 2. That's 44 times 14. Which is all right, so let's set it again. It's 22 times 2 times 14 And what do we get? The area is 616, and this is centimeters squared. All right, so that takes care of C. Let's see what they're asking for D. It says if the cylinder is closed at one end, if the cylinder is closed at one end in centimeters cube, the capacity of the cylinder. So if the cylinder is closed at one end, I'm assuming they're asking us to calculate the capacity of the cylinder. All right. So how much? So what we need to calculate is the capacity of the cylinder. Capacity is just another word of saying what? Volume. Capacity is just another word of saying volume. D. All right. So capacity is asking you how much space is in this cylinder. What is capacity? It means how much space, what can it hold? So capacity is just another word of saying volume. Now, we already know that the volume of all solid shape with a uniform cross section is equal to A times H, where A is the area of the uniform cross section and H is the height. We already calculated the area as what? 616, and the height of the cylinder is 100 centimeter. All right, so 616 times 100 is equal to 61,600, and this is centimeters cube. All right, so C and D. Let's see what's happening now for E. It says if 50 liters of water is poured into the cylinder, calculate in centimeter the depth of liquid in the cylinder. So somebody's pouring water in the cylinder. All right. All right. And this is what they want you to find out. How high or what is the depth of the liquid in the cylinder? That's what they want you to find out. So this is 50 liters of water. 50 liters. All right. So what do we have to remember to answer this? We have to remember that a liquid takes the shape of its container. We must remember that a liquid takes the shape of its container. Now, since the container is a cylinder, it means that the liquid water in the cylinder also becomes a cylinder. And since now the water is a cylinder, the water has radius and it has what? Height. All right. So we're looking specifically at the water. First of all, the volume of water is 50 liters. Now, 1 liter is equal to 1,000 centimeters cube. Told you that already. So 50 liters is equal to 50,000 centimeters cube. All right. So the capacity is 61,000, and somebody poured what 50,000 centimeters cube of water into the cylinder. So the cylinder is not full. What do we know? We know that the water is a cylinder, so the volume of the water, AH, is equal to 50,000. All right, A, which is what? Pi, which is what? 22 over 7, times radius, which is 14, times 14. As a matter of fact, we don't need to do all of that. We actually did it already. The area has not changed. It is what? 616H is equal to 50,000. The opposite of multiplication is division, or we could say divide both sides by 616. H would be equal to, so that's 50,000 divided by 616. The height of the liquid in the container is 81.2 centimeters. The height of water in the container is 81.2 centimeters. All right, so That's the basic idea behind net shape. This is a nice little question on net shape. Um, could the examiner set something like this? Yes, he could. Has he set anything like this in recent history? Yes, he has. So it is something that you need to practice and ensure that you're familiar with it, you understand it, and you can reproduce it if necessary. All right. So this now brings us to the end of our lesson on solids. What must you remember about net shape? You must remember that all solid shapes with a uniform cross section opens out into a rectangle. What else you must remember? You must remember since the solid became the rectangle, there has to be connections between the solid and the rectangle. You must remember that the perimeter of the cross section becomes the length of one side of the rectangle, and the height of the solid becomes the length of the other side of the rectangle. All right. So more lessons to come. Um, until next time.